Welcome to Study Loop.
I'm going to start by finding my stylus. Then I'm going to draw the lower bar. It looks kind of like an L here. I'm going to scroll down a little bit. Okay, this is point C. This is point B. And this is point A. Now, if it made a turn like this, where actually this red one, I'm going to make it solid. That's the Y direction, and I'm going to call this the X direction. So X, Y. All right. I'm going to call this the angle theta. And so if we had a force at point A, and displacement at point A, well, then I could show that the X value is the length right there, which is 10 inches. So right here is 10 inches. Times the sine of theta. And this is the force P. All right, now, if that moves by an angle theta, then the upper bar is attached to it. So this is also going to give us an angle theta right here. And so the Y displacement, X was positive, right? So the Y value, and by the way, I'm going to draw the 30, I'm going to draw the 30 right here. So the Y value is the length out to C, which is 4 inches, times the sine of theta. So this linkage, which I'm seeing how much room I have. I guess I left enough room. The next linkage is going to go up a little bit by theta. And so the displacement here with the 60 pounds is going to be basically the same as the 30 pounds. So I'm just going to add the 60 plus the 30 to give 90. And I'm just going to write the 90 right down here. Okay. Now we've got another bar. Goes like this over to point E, which is constrained to rotate. And then it goes all the way down to point G. And there's also a point F just in here somewhere. I'm going to draw the 80 pounds here. And I'm going to draw the moment of 240 inch-pounds here. And looks like I've got all the forces and the moments drawn. So my next task is that if this right here goes up, y equals 4 sine, kind of 4 sine theta. If that goes up, y equals 4 sine theta, then what angle would this be? Trying to draw a horizontal and then an angle upward. So what I see is that this distance right here is 4 inches. And this distance right here is 6 inches. So if the left side goes up by an angle theta, rises by an angle theta, that's going to be more than the longer one. So it's going to go up 4/6. Oops, I wanted to write this in green. I wanted to write this correctly. The angle is going to be 4/6 of theta. And so this angle with the vertical here, trying to draw that vertical, that's going to be 4/6 of theta, which is the same as 2/3 of theta. And so, X, I wanted red, X equals negative. The distance from the pivot is 15. And then that's also going to be the sine, but now it's going to be 2/3 of theta. So now I'm going to go ahead and do the derivatives. Dx equals 10 cosine theta d theta. Dx equals negative 15 times 2/3. So that would be negative 10 cosine of 2/3 theta d theta. Dy equals 4 cosine theta d theta. And we also have this moment here. Now, to deal with a moment, I note that theta or rather, I'm going to make this phi, is 2/3 theta. So, d phi equals 2/3 d theta. All right, so now du, which is going to be 0, is p, which is in the positive x direction, times 10 cosine theta d theta. So that's force times displacement. Okay. Plus 80, that's in the positive direction, times negative 10 cosines of 2/3 theta d theta. Let's get this one. 90 is going in the negative y direction, so that's going to be plus negative 90. And then the displacement is 4 cosine theta d theta. And now we need to deal with the moment. The moment is going to be a positive moment, 240 inch-pounds. But the displacement, as you can see here, or the rotation, is going to be a negative rotation. It's going to be opposite of the direction of the moment. And so, negative 2/3 d theta. All right, the cosine of 0 is 1. Cosine of 2/3 of 0, still 1. 1. So all of those become 1. All of the d thetas cancel out. And so now I get 10p minus 80 times 10 is 800, minus 90 times 4 is 360, minus 240 times 2/3 is 160, equals 0. Solve that for p, and you get 132 pounds. Where is p here? And the direction is to the right. I showed it to the right, and I ended up with a positive number, so it is to the right.